Hi, my name is Cassandra Champagne, and I'm a PhD student at the University of Michigan, and today we're going to be running the relative density test. First and foremost, you always want to make sure you have your safety glasses on when you're running a test in the lab. Some additional safety materials we have are earplugs, because the test that we're going to be running today does get a little bit noisy. So the first thing that we're going to be doing is going over the equipment that's going to be used for this test. Please feel free to follow along in your lab manual as we go through the equipment and the subsequent procedure. The first piece of equipment that we have is the mold, and this is where the soil is going to be placed. We also have a base plate that will be placed on top of the soil sample with a removable handle that twists off. Then we have a gasket that fits right onto the rim of the mold. And on top of that will go this tall guide sleeve. And into this sleeve will go the surcharge right here. Some additional materials that we have is a digital indicator here, a straight edge, a caliper, a funnel, and a scale. And then most importantly, back there in the red, we have our vibration table. And that concludes the equipment, so now we'll get started with the test. Okay, so the first step of our procedure is the calibration of the mold. So what we need to do is take a few measurements of the dimensions of the mold and our base plate. So to do this, we are going to be using a caliper. If you haven't used a caliper before, it's a really handy device that allows us to take measurements in 3 different ways. We can take inner dimensions, outer dimensions, and depth measurements. The first dimension that we're going to take is the inner diameter of our mold where the soil specimen is actually going to be sitting. So the way to use a caliper is no matter what type of a dimension reading that you're taking, you always want to make sure that you start out in the closed position and zero out the caliper. So next, since we're taking an inner dimension, we are going to be using this side of the caliper here. Basically, we want to extend the caliper until it is snugly positioned with each of those prongs flush against the inside of the mold. Then you want to lift it out and look at the reading output for your measurement. It's good practice to take a few different measurements, so we're actually going to take 3 diameter measurements. So now we're going to close the caliper, zero it out again, and do the same thing at a slightly different angle, making sure that we're at the widest point of the mold, so we're truly getting the diameter. Look at that reading, and then we'll do it one more time at a different angle. Okay, then once you're confident with that reading, we can record that right onto our data sheet. You also want to take note of the units that the caliper is recording in. Most calipers like this one will have a way to switch in between, for example, in this case, inches and millimeters. So just be aware of the units that you're using. The next dimension that we need is the depth of the mold. So in order to measure depth using a caliper, again, you always want to start in the closed position and zero it out. And then this down here, this part, is how we're going to be measuring depth. So we start in the closed position, and we want to place the edge of the caliper right on the rim of our mold, and then we just want to push down until we've reached the bottom. And then this measurement here is the depth of our mold. So we can also record that onto our data sheet. Okay. And then lastly, we need to record the thickness of our base plate. So this is now going to be an outer dimension. So for that, we are going to use this side of our caliper here. So again, closed position, zero the caliper, and then we just want to put it like that. And take the reading and once again record it onto our data sheet. Okay. So that is the calibration of the mold. I'm going to get this out of the way. So the next thing that we need to do is we need to fill the mold with our soil sample. But first we want to record the weight of just the mold itself. We'll also be recording the weight of the mold and the soil after. That way we know the exact weight of the soil that was actually added into the mold. So we're going to come over to our scale. Always make sure that it's zeroed out and make sure the units are proper. then we can record this weight onto our data sheet. Okay. So now we are ready to put our soil specimen into the mold, but we're going to do this in a very specific way. So the first part of the test is to measure the minimum density of our soil. So basically what we want to do is we want to deposit the soil into the mold in its loosest state. And what we're going to use is a funnel. Basically we want to keep one finger under the base of the funnel. We are going to fill the funnel from the top with soil, and then I can show you in front of the mold just so you can see. Basically, we want to minimize the distance that the soil has to travel from the base of the funnel to the top of the current soil layer in the mold. So basically, you're going to start way at the bottom, use a spiral motion to evenly deposit the soil, and then slowly move up as the soil begins to fill the mold. And that's how we're going to get the loosest state in terms of this ASTM procedure. So let's begin. All right, so we have some soil. This is the soil that we're going to be using today. Going to fill up our funnel, and I'm going to start at the bottom. You might be able to hear the soil slowly filling. This will take a while, but this is what's required in order to get this loosest state for minimum density. All right, so I'm just going to keep going, and then we will come back once we're a little bit closer to the top, and then I'll show you what we do at that point. Okay, so now you can see we're almost to the top of the mold with filling our specimen inside. So I'm going to keep going now that you can see exactly how I'm doing this. So again, I'm keeping my finger under the funnel until I'm just at the height of the soil in the mold. We're not letting the soil fall very far. So we really want this to be very loosely deposited into the mold. This is getting stuck in the funnel, that's okay. Going in this spiral motion to evenly deposit the soil. Okay, we're going to keep going, and we're going to overfill the mold. So we want to make sure that the mold is completely full, and then we'll remove any of the excess afterwards. This is looking pretty good to me. Okay. So now our mold is completely filled with soil, and we want to use a straight edge to guide the straight edge onto the mold and just push off any of the excess. Like this. We get to make a little bit of a mess in Soils Lab sometimes. Just want to do this a couple times, do it from a couple different directions. But we always want to make sure that both ends of the mold are in contact with the straight edge, so that we know we're not, dipping into the mold at all. We want it to be a nice, flush, level soil specimen. Okay. And so then once you're satisfied, we're going to take a brush, and we're just going to brush off any of the excess soil on the outside of the mold, because when we reweigh the mold with the soil, we just don't want there to be any soil on the outside that could add to that measurement. Okay. There are also some bolts in here, or some holes where the bolts will go, so we just want to make sure that those are not filled with soil as well. Okay. So now we want to very carefully move the mold from our station to the scale. We just want to make sure that we're not introducing any unnecessary vibrations because we want the soil to currently be in its minimum density state. And then, we only want to densify once we're ready for the vibration table. So just be very careful with how you're handling the mold. Okay. And now you want to record the weight of the mold with the soil specimen inside. Okay. And at this point, we're going to be ready to move over to the vibration table to do our maximum density part of the test. Okay, so now that our mold has been filled and weighed, we're now ready to move on to the maximum density portion of the lab. So we've brought the mold over to our vibration table, and we've already bolted it down to the table, as you can see here. So the next step is to place the gasket that we see here onto the rim of the mold. So then the next step is going to be to take the surcharge guide sleeve and place it on top of the gasket on top of the mold. Okay. And when you do this, you want to pay very close attention to look at the inside and kind of look into the sleeve and into the mold and make sure that the inside of the sleeve lines up with the inside of the gasket and the inside of the mold. That way when we put the base plate on, it's completely in contact with the soil and it's not getting caught on the lip of the mold or the gasket. Okay. Next step is going to be to tighten the sleeve to the mold. So first we're going to come and screw in this knob. And then we have some nuts and bolts on this backside. We just want to make sure that everything is as tight as possible because this vibration table is going to be vibrating quite fast. We certainly don't want anything to come loose. All right, so now just do a quick check to make sure everything seems nice and firm, not going anywhere. And when you're satisfied, we're going to place the base plate directly onto the soil. So we just want to guide it through the sleeve and place it down on the soil. And then, like I said, the handle twists off like that. So now we just have a clean base plate down at the bottom. And on top of that is going to sit our surcharge. So now we're just going to lift the surcharge, guide it through the sleeve, and set it down on the base plate to be applied evenly to the soil specimen beneath it. And it's important to note that we could certainly be adding more weight, and we can certainly be vibrating the table for a longer duration to achieve a higher density. However, when we're doing this maximum density test, it's important that we follow the ASTM procedures such that we're achieving the same maximum density that the rest of the industry is also achieving. So now our surcharge is loaded, and we are ready to get started. So we want to make sure that we remove anything from the table before we start vibrating. So let me just set those aside. Okay. And at this point, we're going to want to put our earplugs in, as this is going to get quite loud. So now this is how I'm going to control the vibration table. We are going to set it to an amplitude of 100, but we're going to start out at 0 and slowly ramp it up. And then once we get to that amplitude, we are going to start our timer and vibrate for 8 minutes. Okay, so after we reach that 8-minute mark, we can just kill the vibration table and we can see what we have. So the first step is going to be to lift the surcharge load off of the specimen. And now we can get started removing the guide sleeve. So let me just get my tools. Okay. So now let's just loosen these up. So now we can just set this aside. Okay, and we can remove the gasket as well. But we do want to keep the base plate on the sample. Be sure that we do not take that off quite yet. The next step is going to be to measure the height of the base plate with respect to the edge of the mold. So for that, we're going to need our digital indicator. Okay, so here is our digital indicator. So it fits right into the side of our mold, and it works very similarly to the depth measurement of the caliper. So basically the measurement will change based on how far this probe is allowed to extend. So we are going to start with the probe sitting on the edge of our mold, and this is what we're going to zero the indicator out at. So we're going to hit this button and set the display to 0. So now we're going to take 3 measurements on each side, 1 measurement here, 1 measurement here, and 1 measurement here. And then, like I said, we're going to repeat for the other side. So if you look at your data sheet, right now we're doing the left dial reading, reading number 1, reading number 2, and reading number 3. So this is zeroed out. So we're going to go ahead and take our reading number 1. Okay. And then we're going to take our reading number 2. And our reading number 3. Okay. Now for the sake of this video, we won't show it happening on the other side, but it's the same exact procedure for the right dial reading. So now we're going to remove this. That's the end of the procedure, but I do want to show just how much our specimen did densify. So I'm going to take off this base plate. Okay. So if you remember, our specimen was flush with the top of the mold when we started. So you can see it's almost approximately, it looks like the thickness of the base plate is how much vertical displacement that we have here, and that's all due to the densification of the particles interlocking into each other due to the surcharge and the vibration that we applied. So it's a really cool experiment that you can actually physically see what's going on.